Understand the definition of partial pressure. According to the ideal gas law, the partial pressure of any individual gas, I, in a mixture is determined by the formula P I equals NIRT over V, where Ni is the number of moles of that specific gas, R is the gas constant, T is the absolute temperature, and V is the volume of the container. Analyze the conditions of the addition. Argon, Ar, is an inert noble gas that does not react with either number 2 or N2O4. The argon gas is added at constant volume. The glass tube is rigid and its size does not change. The temperature, T, of the system is held constant at 70 degrees Celsius. Determine the effect on the reacting species partial pressures. Because the container volume, V, and temperature, T, are constant, and the number of moles, N, of number 2 and N2O4 inside the tube has not changed, their individual partial pressures, P number 2 and PN2O4, remain completely unchanged. Note, while the total pressure in the tube increases due to the addition of argon atoms, the partial pressures of the reacting gases do not change. That asterisk evaluate the reaction quotient. QP. The reaction quotient is defined as QP equals P number 2 to the power 2 over Pn2O4. Since the partial pressures of both number 2 and N2O4 remain the same, QP remains exactly equal to the equilibrium constant Kp 3.0. Because QP equals Kp, the system remains at equilibrium and no shift occurs. Conclude, since there is no shift in equilibrium, the partial pressures of the reacting species do not change, which identifies option D as the correct answer. The correct answer is option D. No change will take place.